Hello there, everybody. Hope you're doing well and doing okay with your online classes. Obviously, this is not ideal, but I think we're going to make it through it. Got another lab to do. This is a lab that you're going to be doing, obviously, in the classroom. Instead, we'll be doing it on my kitchen island. This is with Unit 11 on refraction. So we just finished up Unit 10 on reflection. We looked at reflection in mirrors, and in this unit, refraction and lenses are going to be the main content for Unit 11. So this lab you're going to be doing is one that was always fun because students got to use lasers, and anytime students use lasers, they tend to have a lot of fun with it. So we're going to be using these little handheld lasers and measuring how light refracts. So you might remember from earlier units that refraction means to bend. So reflection is a wave bouncing off a medium. Refraction is a wave bending through a medium. So you're going to be doing a lab, or we'll do it together obviously, where light's going to bend as it goes from air into glass. And we use these semicircular dishes because it's going to confine the refraction to just this front end. So I'm going to dim my lights in my kitchen so we can see the laser light. So here's laser light. And we notice first, if I shine it straight in, and I also have to make sure I'm going through the radius of that semicircular dish. If I shine it straight in at 0 degrees, and we're using this polar graph paper that allows us to measure the angles. So it's got all the angles preset on them. So if I shine light in at 0 degrees, it goes straight through and comes out at 0 degrees. Light does not refract if it hits a boundary straight on. If it hits 90 degrees with respect to the boundary, or what we say in physics, an angle of incidence of 0 degrees. But now if I open it up to say 20 degrees and shine the light at 20 degrees through the center, it comes out at about 14 degrees. Definitely a change in the angle. And anytime I go from a less dense medium like air to a more dense medium like glass, I'm going to have a smaller angle. If I go in at say 40 degrees, go right through the middle, comes out at about 28 degrees. If I go in at say 60 degrees, comes out at maybe 40 degrees. There's also a little bit of reflection that you can see right there. Anytime light refracts through a boundary, like from air to glass, there's always a little bit of reflection. And that's why you see, when you look through a lot of windows, a partial reflection of an image as you see the refraction looking through the glass. So if I go from air to glass, I get smaller angles. Likewise, if I flip it around and go from glass to air, I'm going to get bigger angles. So again, 0 degrees in, 0 degrees out. If I go in at say 20 degrees now, through the middle, it's coming out at about 34 degrees. If I go at say 40 degrees, it's very difficult to do this with just two hands, so forgive me, but if I go in at 40 degrees, it's coming out way out here. It's very faint, way out there at like 70 degrees. So now I'm going from a more dense medium, glass, to a less dense medium. I'm getting greater angles. And one interesting phenomenon in physics that we notice is if I go beyond what's called the critical angle, which for this glass is about 45 degrees. So if I go beyond that about 50 degrees and shine it in, no light refracts. In fact, all the light internally reflects. And as it does that, it obeys the law of reflection. This is a property known as total internal reflection, which has many applications. It's used in fiber optics, it's used in medicine. Some of those applications we'll probably talk about later. So if I go beyond the critical angle, light no longer refracts, it only reflects. So we're going to be testing glass, and the other medium we were going to test was water. So here's a semicircular dish of water, and we'll notice the same things. Water is obviously more dense than air, so if I go from air to glass, I'm going to end up with a smaller angle. Again, 0 gives me 0. If I go in at, say, 20 degrees through there, I'm going to come out at about 14 degrees. If I go at, say, 30 degrees, light's going to come out at about, looks like 24 degrees. If I go to 50 degrees, light's going to come out at, it's very faint to see, but it looks like about 32 or 34 degrees. And likewise, when I go from more dense to less dense, from water to air, the opposite would happen. So if I shine in at, say, 20 degrees now, making sure I go through the middle, it's coming out at about 28 degrees. If I shine in at 30 degrees, it's going to open up to a bigger angle, about 38 degrees. And for water, its critical angle is about 48 degrees, 48.8. So if I go beyond 48.8, say 50 degrees, I'm going to see that total internal reflection again. Where no light goes through, all the light is internally reflecting back. It's very hard to see with water on the video, but it's definitely happening. Again, it's called total internal reflection, when all the light internally reflects back. So there's a little demonstration of a lab that you would have done. Again, another fun lab. So unfortunately you weren't able to do it, but hopefully this video makes sense and it helps in your learning. So hope you're all doing well, staying healthy. Hopefully your online classes aren't too difficult, including honors physics. Miss you guys, and hopefully we'll be able to see you in a month or two. Take care, everybody.